Right.
Hi, I'm Dean Kershaw, Kershaw Instrumentation. We're here today to talk about our newest product, roll density tester model RDT16U. Some of you may be familiar with our older testers that we've been making for a number of years. This machine essentially does the same test, but it has many improvements over the older versions, which we will discuss during our presentation here. Um, the new machine is a little bit smaller than the existing one. Also, all of the electronics are contained within this flat screen PLC, so we don't have any of the digital meters or the switches or the controls like we had on some of the previous models. What I'd like to do here today is we're going to run just a couple simple tests to demonstrate the principle of the machine, and then we will go through in some detail each of the screens, and I will show you some of the features that are present within this current design. Now, for those of you who are not that familiar with this test, the way this test operates is we have a moving sled, which you can see is actually moving to the left and the right here, and upon that moving sled is a load cell, which is this device right here, and you can see if I push on that load cell, we get an increasing value on our force. We're going to talk about all this in a little bit more detail. But the way this machine operates is as that sled, when we start to test, the sled will move, the probe will come out, and it will touch the roll. And the instant that we come in contact with the roll, this device senses that we've made contact with the roll. It will set our displacement to 0. Now what happens is that as we start to penetrate the roll, we're measuring the displacement as the force is increasing on the probe. We have a preset force that's programmed in here. When we reach that preset force, we end the test and we lock on the display how much penetration we had to generate that preset amount of force. So with that being said, a soft roll will give us a large number because we have to penetrate the roll very far to get to that preset force, where a hard roll will get a smaller number because we won't have to penetrate the roll as far to get to that preset number. And the preset value is adjustable, and I will show you how we actually do that adjustment in a little bit. To help aid in our discussion, I'm going to go ahead and actually run a few tests here, and you will see the mechanics of this thing as this thing operates. So we start out by taking the test roll that we want to test and putting it on the spindle. We push the start button. You'll see the sled start to move. Everything is at 0 at this point. Nothing is happening. The instant that we come in contact with the roll, the force goes up, and we have a displacement of 2.2 millimeters. So what that's telling us is that we had to move 2.2 millimeters into that roll in order to generate the force that we needed. Okay? We'll rotate the test and we'll just run it again just to review. So nothing's happened. We haven't touched the roll yet. And there's our 2.2 number again, which means that the firmness of this roll is relatively consistent. Now, this brings me to my first topic here. You'll notice that we have a large distance between the roll and the gap. That's roughly about an inch, maybe 25 millimeters. Well, that's wasted time because as we run the test, we have to stand there and we have to wait for that probe to move all the way in and all the way back. So we have a feature here that we didn't have on the other devices where we can actually adjust that so that we can tailor the position of that probe to suit the roll, and I'm going to show you how that's done right here. There's a button on our main screen that says reset sled position. So what I'm going to do is I'm going to go to this screen and I'm just going to hold the right arrow down until I get to within maybe 3 or 4 millimeters. That's good right there. You can see we've got about a 3 or 4 millimeter gap. And now we're going to set the diameter. Now when we run the test, it only has to go a short distance, so it shortens our test time considerably because it's going to stop at that new location every time. Okay? Now, if we're going to change rolls, sometimes that's going to change our diameter. So for example, we're done testing this particular roll. Now I want to test this paper towel roll, which as you can see is very spongy, so I would expect to get a much higher number on this than I did on this firm roll. Now to check this roll, what I'm going to do is I'm going to move this pin down to the 11-inch position, because this is an 11-inch roll. We're going to slide this over the spindle, but you can see we're too close. So we'll go to the reset position. We'll back this up. So we get to a nice comfortable position, and we're going to set it there. So we've now reset the probe based upon this new roll. Now we're going to start this test. And there's our penetration. We went 9.2 millimeters on this roll, which is obviously a higher number than we got on this roll because this is a much softer roll. But we can rotate this around and try it again. 9.6, so it's consistent, okay? Now very often what the operator will do is they may check several vectors around the roll in terms of the firmness, because they want to see about the symmetry of the roll. In other words, I get a firmness number, but is that firmness the same all the way around, or does it vary as we go around the diameter of the roll? That's a test. Now I had mentioned about this pin here. This pin is all the way at the bottom. When I put the 11-inch roll on, that puts our test at center line. We want to test pretty close to the center of the roll. If I move it up to the top and I put a 4-inch roll on, again, we're at center line. We also have a hole in the middle, and this hole in the middle would be for a roll such as this, which I believe is a 7-inch, is a 7-inch height, 7-inch width. So with that pin in the center, if we put this on, we're going to talk about these rolls with the larger cores a little bit later on. So in summary, by moving this pin around, we can adjust for the various roll widths so that we do our test at center line. And of course, if you have a roll that is a different width than any of these, you simply install another hole to accommodate that. Okay, what I'd like to do is I want to talk a little bit about some of the design features in this PLC. When you turn this machine on, it goes to our standard operating screen here, which I think we've demonstrated pretty thoroughly. If I go to my mode screen, this is pretty much the root of the system. We have a large button here that takes us back to the run test. We also have a test panel, and what the test panel is merely for troubleshooting purposes. If I go to this area, it tells me I can apply force to the load cell, and I can see the force numbers going up, both the raw form and the calibrated form. I can tear that number here. I have a forward and reverse button if I want to check to make sure that the motor is properly working. I can just jog it, and you can see that our displacement circuit will work with these buttons. So that ensures that the motor is working properly and that the displacement circuit that measures the position of this sled is working properly. We also have limits in here, which I'm going to talk about in a moment. In fact, this is a good time to talk about it. You'll see we have a low set point and a high set point, and right now they are both under. And if I press on the load cell, as soon as I go over 6, this tells me that the low set point worked, and as soon as I go over 600, this tells me that the high set point works. So I can verify that my set points are working properly. Now, the purpose of the set points, if you remember at the beginning of our discussion, I was describing the principle of operation. What's happening is that probe is moving, and nothing is going to happen until the force exceeds the low set point, which is 6 grams. So the probe is coming out, it's coming out, nothing's happening, nothing's happening. The instant that we touch this roll, we exceed the low set point, and we now start our test or our displacement process. Now what happens is that probe continues to move, our force is going up, going up, going up, and eventually we exceed 600 grams, and at that point we exceed the high set point. It takes the displacement measurement, locks it on the screen, and we'll store it until we start the next test. I think we demonstrated that earlier, and we're going to be running some additional tests later on. Now, if by any chance you want to change those set point readings, we can go here to, we're going to talk about the calibrate. In the calibrate screen, we go over here to the set point area, and all I have to do is, if for any reason I want to change that set point, I merely just touch that, and I can enter the set point that I want, both high and low. And that the only reason you would want to do that is if you want to change the parameters of your test. You want to see the effects of the roll hardness with higher or lower forces. This is where you would make those changes. We also have a force calibration section. Now in the force calibration section, I'll actually walk you through this, but we have a little picture diagram that that walks us through the process. I'm going to read what the screen says. It says to remove the cap screws and stand the load cell assembly on end as shown with no weight. So we're going to go ahead and do that. It's only going to take me a moment here to get this apart. So what the picture is showing us is we're going to take the load cell off and we're going to stand it on end like that. Now we have the load cell essentially with no load on it. We're going to push the yellow button, and that now has established a zero condition for the load cell. Now the picture tells us to apply a 1,000 gram weight to the load cell as shown. So we're going to put a 1 kilogram weight on the load cell. So we're now exerting 1 kilogram force on the load cell. We push set, and our calibration is complete. So now it's telling us to put the load cell back using the cap screws, which I will do very quickly here. And this machine is ready to operate. There really are no other calibration. Well, there's no other calibration required on this machine other than checking, verifying the calibration, which we're going to do here in a moment. Let me just get this screwed back on here. Okay, there's 2 screws. I have one tight for now. That's good enough. So we have finished the calibration. So all of our calibration is done on this machine. Now we have a couple more buttons. We have a help button, and what the help button will do is if you ever have a question about any of the controls or the displays on here, you go to this area, you just touch it, and it will give you a written description of what the function is of that. For example, if I want to know what the force display is, I touch that and it will give me a description. Now, in addition to that, we also have an instruction section, and we'll go through that. In the instruction menu, we have 4 different sets of instructions that are programmed into this thing. For example, the first one is it just walks you through, when you get this machine for the first time, how you're going to set it up and get it ready for operation. The second one, I'm going to go to the running a test, the yellow button here. This is what I had demonstrated earlier. It tells you about setting the position of the probe and how to install the roll and how to actually run the test. And then there's a picture of the start button, and it tells you about how to perform the test. The spring calibration, we're going to talk about that next. We've done the calibration on the machine. It would be nice if we had some way of verifying that the calibration is done correctly. So if we touch this light gray button, it will walk you through and show you the procedure that we're about to do, which I won't discuss here because we're going to actually do it. What the spring calibration is with this machine we supply a device that looks like this, and essentially this is a carousel with 3 different springs. Each of these springs represent a known density or a known firmness. For example, the short spring would represent a roll that would be very hard. It would have a firmness of only in the order of like 2 millimeters. This one here is a very soft spring, so this would represent having a roll with a firmness of in the order of like 10 or 11 millimeters. And this one here is somewhere in between. So what we want to do with this is we'll put this device on, just exactly the same as we would the roll, and we'll actually run a test. So what we're doing is we're running a test on this simulated spring, and in this case we got a firmness of 11.3, and that is within the specification. So this is just a way for us to verify that the calibration was done properly. Most customers that have these, they will do the spring calibration on a daily basis just to ensure that the machine is working properly. This one should be between 4 and 4.5. We got a 4.3. And generally we want to run a couple of cycles on each of these springs to ensure that everything is working properly. This is just a confidence builder in terms of making sure that the machine works properly. This should be usually around 2.5, and we are right there, okay? Now, as far as what these numbers mean, if you look in the instruction manual, it will tell you what these values are, or if you go to the instructions for spring calibration, the last page, there's a little spreadsheet here that tells you what the acceptable firmness values are for the 3 various springs. That's shown in this gray box here. The last part of our demonstration has to do with different core sizes. And again, we have instructions here with this darker gray box that'll walk you through the process that we're about to do. There's a little picture illustration, but we're going to actually do it here. You'll notice the rolls that we've tested so far have been relatively small core sizes. This particular one is a 2-inch core. This one here is a 1.5-inch core. Now on the older machines, we supplied one spindle that was good for like 1.5 inches to 2 inches. And if you had a roll that was a different core than that, then you had to purchase another spindle with a different size. And then you were in the saga where you were constantly switching spindles based upon the rolls that you wanted to test. On this new machine, we've improved the design where we merely add spacers to this existing spindle to make it accommodate these larger sizes. For example, here's a roll that has a core size of 2.25. Well, our spindle, as we have it set up here now, will go from 1.5 inches when it's totally compressed to only 2 inches when it is uncompressed. Let me back up this sled out of the way here so we've got some room to work. Now, you can see if I put this on, this is a loose fit. And first of all, you want to move this pin up to the 7-inch position. But you can see this is a loose fit because the spindle is too small. So with your machine, you're going to get a kit that looks like this, and there are various spacers. And each of these spacers are identified in terms of what their size range is. For example, this is 2 to 2.5 inches. Well, our core is 2.25, so this would be the one that we're going to want to use. So what we're going to do in this case is we remove this screw, and this is all spelled out in our instructions here. And we remove this pusher from the machine. This is the pusher assembly. Then we're going to take this longer screw and the spacer that is labeled as 2-inch, and we're going to install this on the machine. And we obviously have 2 of these. So we're going to put the other one down below. And you can see now we have a nice firm fit, because we've now increased the spindle so it'll accommodate rolls from 2 inch to 2.5, which are right in the range that we want. Now, if we have a roll with even a bigger spindle, such as this, we need a 3.25 for this. We have a set of spacers for 2.5 to 3 inch, and we also have a set of spacers for 3 to 3.5. If we were to put this longer spacer in, we would be able to accommodate this roll here. And again, the nicety of this is if you have rolls with different roller core sizes than we have shown here, we simply just supply you with a different spacer to accommodate that particular roll. And I will run just a couple more tests with this bigger roll, and that will conclude our demonstration. So we're going to put this large roll in, 7-inch face width, 2.25-inch core, and we'll go ahead and run a test. Okay, it's a pretty firm roll, so we only got a displacement of about 3 millimeters. We'll rotate that. We'll test it again. 2.6, so it's consistent. We'll do one more. Three-inch, so 3 millimeters. So, and that concludes our presentation on this tester.